Mr. Zhang, Joey, and John have just ended the chemistry lesson in the science laboratory.
Okay, so that's the end of today's chemistry lesson. Don't forget about doing your homework about the electrolysis tonight.
Come on, electrolysis sounds so boring. Is there anything more chemistry? I'm also colorful.
Joey, I understand you. I think it's very boring too. But I have a better idea. Let's go find Mr. Zhang and talk about it.
Yes?
Hi, I would like to do some experiments on electrolysis. Could we borrow the apparatus for the experiments?
Yes, I will observe it. Please take your time.
Okay, thank you.
Wait, remember to wear the safety goggles and wear the lab coat.
Okay.
Okay, so let's get our setup. Okay, so let's start the experiment.
Okay, great.
Let's pause the video here and take a closer look at their setup. From there, we can see a DC power supply, a pair of graphite electrodes, sodium sulfate and electrolyte, and 4 solutions with different colors. Seems that they are going to carry out electrolysis.
Wow, that's cool. But why is it happening?
Oh, this is a good question. Perhaps you can have a guess first. Okay, so let me give you some hints. I've actually drawn a diagram over here. You can refer to this diagram and you can think about why.
I think I can explain why 2 different colors appeared in the solutions. During electrolysis, mobile ions are attracted towards the electrolyte with opposite charges.
Yes, you're right. At the cathode, which is negatively charged, hydrogen ions are preferentially discharged to form hydrogen gas, while at the anode, which is positively charged, hydroxide ions are preferentially discharged to form oxygen gas.
So this causes the solution near one of the electrolytes to be acidic, while the other to be alkaline.
Yes, you're right. But do you know why the solution is flowing?
I think there must be some kind of forces causing it to flow, but I'm not sure.
Oh, so actually I've put a strong magnet under this white towel. So let me show it to you. Ta-da! Okay, so this strong magnet actually provides the magnetic force to the moving charges, and this causes the solutions to swirl.
Oh, I see. I have some ideas now. Is it the magnetic force acting on moving charges?
Exactly. As you said, these mobile ions are attracted towards the electrodes with opposite charges. They experience magnetic force as they move in the magnetic field. In fact, you can predict the water flow by determining the direction of magnetic force acting on the charges. To achieve this, we can apply Fleming's left-hand rule. Suppose that the positive charges flow from the electrode on the right to the left. We say that there is a current to the left. If the magnetic field points downwards, we can find that the magnetic force points towards ourselves by applying Fleming's left-hand rule. That is why we can see the solution flowing towards us. Indeed, if we reverse the direction of either the current or the magnetic field, the water flow would be the opposite.
Oh, what are you guys doing? We are doing an experiment on electrolysis. It's incredibly interesting. Oh, really? That's much more interesting than what I thought. Yes, I can't imagine that we can combine chemistry and physics concepts together.
Yes, science is really fun and there's a lot more for us to explore. Okay, so now it's time for us to do the electrolysis homework.
Okay, bye.
Where did they go? Hi.
Remember to wear the safety goggles and 你哋要叫我㗎。
咪係咯。
你哋係啊，你哋係